Yeah, hi. Thanks a lot for having us here. Today I'm going to talk a little bit about how we ended up building Androids in a different way. Before I start, a couple of sentences about myself. So as you introduced me, I'm Simon. I've been developing since, I don't know, 4th grade or something like that when I was writing in QBasic. And I started with Android at Android version 1.5 or something like that, so quite some time ago. Just last year, I transitioned a little bit to Kotlin. This became my new hobby. And, well, I have been Playworks for the last, I don't know, 7 years or something like that in different roles. Today it's all about hardware and how we extend testing. To follow along, you don't really need to know much about what we do in the end. And luckily, I had Leonid here already talking to you about what we actually do. So if you remember 2 things, I'm already happy. One thing is that we build SDKs. And on the other hand, those SDKs talk to physical terminals. They look like this, so not the thing that you normally see at your grocery store, but really things that you would carry around and that you want to pair actually with a mobile phone. Why did we actually build robots? We needed some way to verify that our implementation actually works also end-to-end. This is what came out of that in the end. So normally when I talk about testing, half of the group turns away. The other half just turns silent and nothing happens. But quickly just look at basically what does it mean to test. Yeah? And if you're a seasoned developer or if you're just a newbie starting just new, you're more or less confronted with 2 philosophies and 2 pictures. One is the life cycle of testing. This is more about talking about an iterative approach of test-driven development that enables you to really also then, without any problems, refactor without having any fear. And this is like the continuous circle. And the other thing that you're basically seeing, especially on the Android developer pages quite a lot, is the testing pyramid. And there you start with unit tests on the bottom. Those are really the tests that test individual pieces of code. They run really, really fast, and you should have thousands of them in your code base. It's actually what we have in our side. Yeah? And this is really the thing that tests the individual implementations that you have then. One level up, you have the integration tests. And they normally test how different modules, frameworks, fragments, view models interact with each other and what they do. And in Android, you would normally use, for example, Espresso or Mockito to mock certain aspects of that and go through the Android lifecycle as part of that. And then on the top part, you have the UI tests. And those are really the expensive ones. You normally don't have that many of them. They take a long time, but they really then glue everything together and do what a normal user would actually do when they were using the app. So this is what we are confronted with. Let's have a look how this looks on our side. So we have something running on an Android phone with our SDK integrated. And, well, on the unit test side, yes, we have them. On the integration tests, yes, we have them. As it is with integration tests, you can always have more. So that's also one of our challenges for us. UI side, well, Lindy said we don't really have that much UI, but I would say, well, this is also doable. And we even got farther, and for example, we mock our HTTP connections, which relates a little bit to basically integration tests. So we test all connections in and out of our SDK. And then we come to, external terminals. And then the question is, OK, what do you do there? You could argue, well, we mock our terminal, so let's put a check mark after that because, well, hey, we have it. But if I look at it, I say, no, we don't really have those tests. At least this is what we didn't have, I don't know, I think we started this 2.5 years ago or something like that. So if you look at the problem that we have, what we want to do is actually, so we want to test end-to-end coming from a physical card that you have, going to the actual terminal that is somewhere at a POS system and wants to be used, going through an actual Android phone running the SDK in some capacity. And then from there on, even going further, we run most of our infrastructure on AWS. So in our case, it will go to AWS. And from there on, it will end up at some bank. And then the bank will decide, yeah, I'm approving this payment or I'm not approving it. And this put us basically into a problem, because I don't want to sit there every evening testing our new code base if this whole chain still works. So we had to get creative. Yeah, we had the new challenge, and it took some time until we figured out what we can actually do. In that period, there were quite a lot of manual tests that we and everybody else in the office basically were sharing as part of that. And well, it wasn't the nicest time. Well, our quest that we put aside for us or set out for us was that we need something that can actually interact with a physical terminal. So that's a thing that we are missing. In addition to that, it would be nice if this just integrates with our CI system so that we don't even have to basically start it manually or care about when to run it or something like that. And we want to have it easily manageable and extendable. So there shouldn't be this one guy sitting somewhere and being solely responsible for it. And if it breaks, then he is responsible for fixing it. And if he's on vacation, then, well, we're fucked. We're not releasing for 2 weeks. Yeah? So that's not what we wanted. If you look at the last two items, I think this is somewhat achievable. In the end, we decided to use Cucumber for our test definitions. It comes more from the TDD approach, but it really helps you to just easily write down the codes or the tests that you want to run. I'll have some examples later on. And well, the CI runs Gradle anyways. Cucumber is integrated in the JVM, so there isn't really much problems at this point. But we really scratched our necks on the first one. Well, what's the first thing that comes to your mind when you think about building robots? For us, it was Lego. And luckily, Lego also builds robotic components that you can use for something like that. And, well, we just gave it a try. What could we lose? Building Lego, if it comes worse to worse, we had a lot of fun on a weekend building Legos. Luckily, it turned out good. I just want to give you a quick introduction or a quick insight into what we actually built out of that and what we had running then over at our place. So we actually built like a small Lego robot out of different Lego components that featured different components to really insert a card. In the end, it will also enter a nice pin as part of the transaction. And the fun thing is, whenever somebody came to the office, like a client, a new member of the team or something like that, this was the first thing that they were going for. Hey, I want to see the robot in action, yeah? Well, that's what we had running for. Okay, we should do it later on.
This was connected to CI?
This was actually connected to a CI, yeah? So all the quests that we set out for us were fulfilled with this one already, yeah? And well, we had this running in the office, and this was the go-to point, and everybody's eyes were just blooming up when they were seeing that. Yeah?
Question, what about this QR code, which was visible on the screen of the robot?
This you can ignore. It wasn't doing anything. This was just for debugging purposes on our side. So it didn't really add much point at this point. It was just to better identify in which stage we are in and how to connect to it, actually. Well, you have seen how it works, and this was actually testing our production code for, I don't know, a year or something like that. Well, if it works, right? But you have also seen how slow it is. And, I mean, you probably know Lego. It's pretty fragile. So it tended to break from time to time, and then it was on us to actually fix it, which is overall fine. But it became more and more and more. So we set out, OK, what can we actually do about it? Lego is all fine, and it basically proved our point that we can actually build something like that. And at some point, we ended up at iteration 4, so we had 2 and 3 in between. But with iteration 4, we really wanted to basically build something which is solid and which keeps on running. So we got out our tools. We ordered some actual like sturdy hardware. Those are like aluminum bars. You order a lot of electronics and different moving parts. You design your own PCB where you can put some electronics so that it's nicely packed up. You print some 3D components that you designed specifically for that use case. You whip out your soldering iron, and you just start building. So this then started as a weekend project and ended up as like interactive sessions in the office to build more and more of those robots. And yeah, well, what you end up with is actually something that vaguely remembers you maybe like a 3D printer or something like that. But it's actually something that can do the same thing as the Lego robot did, just much faster, much more reliable. And right now we have this running for a year in the office, and we had absolutely no issues with breaking down or speed issues on that one. And I thought, well, if I'm here already and talk about this, why not bring one? So this is actually one that's working. And I want to quickly go through this with you to show you what we actually have there. I hope you can see this. Let's see. So what we have here is our normal terminal, just strapped in here, so it cannot really move. Then we have a gantry that moves the finger, that positions how or which button should be pressed. And this is driven by a pulley system that's normally used in 3D printing, so it's really precise also. And you can really target the button that you want to touch in the end. And in addition to that, we have some, so this is driven by some stepper motors, and then we have some servo motors which then do the actual movement of, for example, presenting the NFC card or pressing a button or inserting the card. And all of this is driven by a Teensy. It's similar to like an Arduino, just a little bit smaller and a little bit more powerful. And in the back, we have a small Raspberry Pi, which runs a web server in Python. And this is how the outside actually communicates with this thing. So everything that runs a test, that wants to see some movement, just talks to a REST interface or like makes a GET request basically to the API, and that's it. Well, I would say let's see in action, yeah? So I was talking about the API that the robot has. Well, it's not so sophisticated. It's really easy. You make a GET request to a specific endpoint, and you just tell it, hey, please press item buttons 1, 2, 4, 5, and then after that, OK. And let's see if that works. Just have to somehow mingle my hands and my microphone. So I'm sending this request, and you see that thing actually doing what's supposed to be. And that's what we actually in the end wanted. So we want to have something which can talk to or interface with different kinds of terminals that we have implemented on our side and have it just run sitting on a shelf and run as part of our CI builds. And well, that's our solution for the moment. As I said, it's running for a year now or less, or something like that. And at the moment, we are continuously adding more of those. Also, our terminal estate of what we support is growing, so we don't have any shortage on building new ones in that case. But now let's have a quick look on how this actually looks on the technical side when it comes to running this from your normal test runner. So I was talking about Cucumber. And how this normally looks like is you have a definition of your test case that's written in a very high-level language. So you really say, hey, I want to execute an NFC, a contactless transaction, and I want to start it for €2. During running through that, I want to receive certain callbacks from our SDK. That's what the integrator would see. So when they start a transaction, they would get those callbacks informing them what stage of the transaction they're in. This is what we would also expect in our test case, that we get exactly those back and not more, not less. At some point, we then present the card, basically either insert it or swipe it over. And then we want to see additional data coming in. And then in the end, we want to have an approved transaction. And well, that describes the one test case. Today I just brought a couple of them so that you see different actions that the robot can do. And I would suggest that we just run through two of them, which we call smoke tests. They're just sanity tests, which can be done really easily. And in the end, I just click run, as you would do with any other unit test or anything else like that. And while it runs in the background, you would then see that we just inserted the card. It was accepted. You see movement on the terminal about processing the transaction, and in the end, that the transaction was approved. And then we have a second transaction that we test, where we actually just show the NFC card. And well, looking at the run result. This just gives me then the green light that everything was done properly. And well, we have seen the feature files. We have seen what this would trigger then. Now the interesting question is, how does this writing as a feature file translate to actually some action? And in Cucumber, this is done through something that's called step defs. And that's basically a link from the text that you write to actual code. And in the end, it turned out actually to be relatively easy to map certain actions that you write high level to individual steps, because everything that you write in the feature file normally translates to just one action that we actually want to do. And for example, if I write in the feature file, hey, I want that the customer insert the card, then this just translates to a call to this robot with an HTTP GET request, and that's it. I don't care about anything else. I just make this call. If I want to remove it, same again. I just tell the robot, please remove it. And that's basically the translation to the actual hardware. If we look at the steps for the transaction, it's similar. So I tell it how the SDK should be initialized. I'm giving it some parameters, and this just translates then also to interaction with our SDK. So I say that I want to configure it with a certain credentials. In our case, it's just a mock mode because I don't want to basically rely on the internet here. So I just have it run in a mock mode. So there is no real backend connected at the moment. It's talking to a virtual backend. I tell it, hey, I'm talking to this is a Verifone terminal that we are connecting to. And whenever I get status change callbacks, I want to queue them in a queue. And same goes for the completion callback. And well, in the end, I just check that I received all the status updates that I wanted to receive in the end. And well, this now ties everything together. But what we don't want is that either with each commit or that on every branch we always run the same test, which in the end run 20 minutes or something like that. We want to be able to control this in a little bit more controllable fashion. And that's the cool thing about the feature files. You can annotate the different scenarios that you're running. So for example, here's a set, hey, all of those scenarios in this file, they are using the actual chip card, so inserting a card. And this is, for example, is a smoke test. So if I just want to have some basic sanity checking, then I would just run all the scenarios that are that are annotated with this smoke. I also went away as far to say, hey, this is a no CVM transaction, so I didn't have to enter a PIN or anything like that. But for example, in our test runner, which actually then just runs the overall unit tests or Cucumber tests, I can tell it what kind of scenarios it should run. And well, let's go ahead and, for example, run a pin test case. Then we see the robot also a little bit more in action. And this is also something that we use on our CI. that we use on our CI, that depending on which branch we're on, or if we're building for a release or just a staging release, then we build different kinds of flavors in there, and then just have a subset of tests running. So this is now a transaction that requires a pin entry, and we see the hand moving along, entering the pin, and in the end finishing up. Card was removed. We got an approved transaction, if I read this correctly, and we have the same then also with NFC. So it's very, very similar. It just gives us then also in the end trust in the code that if I go home, I haven't really broken anything crucial. And that's our first line of defense, basically, for catching those mistakes. And in the end, we had a green test case again. All right. So we now have a robot. We have it integrated into our CI. What do we do from here on? Just a quick recap what we have right now. So actually, we have a small army, but it can grow. We have around 25 different scenarios of using combinations of different CVMs, so PIN, signature, none, NFC, ICC. We also have different kinds of transactions. We have refunds, we have actual sale transactions. We have also something which is called a motor transaction. We actually enter the account number, the credit card number, manually on the terminal. And well, this gets tedious manually, so I'm happy that we have the robot. And well, adding a test is more about writing feature files than anything else at this point now. And well, we have this triggered X times a day. So more or less every commit triggers a new run on the robot. Went as far as us actually really breaking terminals because we were doing too many transactions, and the contacts that then interacted with the chip card, they oxidized and broke off there. So that's also the fun parts of then doing testing in that amount. But it really helped us to believe in what we basically give out and know that we haven't really broken the most crucial part at this point. And, well, I talked about adding this to the CI. This is a screenshot from a couple of days ago, I think, for our Java SDK that we release. And in here you can see a couple of robot test stages that we're running through. And in the end then publishing to various Artifactories or Maven repositories. And well, in the end it's just good to see this when you either come in the morning or leave in the end of the day. And this is really what keeps us going and also motivates us to keep the robot running because we know whatever the robot is not doing, we have to do manually. Yeah, so some final thoughts. Testing can be fun. It's about what you make out of it. I also understand that it's not basically for everyone that building a robot is the first idea that you should have at this point. For us, it really made sense. We actually have physical hardware that we want to test, and this becomes one of the prime examples. It took some time since until we ended up at this point. You saw the Lego. I didn't show you iterations 2 and 3. I didn't want to. And well, in the end, you would also think, okay, yeah, how do I build something like that? Yeah, we all started without that much knowledge. Some of us had some experience with electronics, but most of that was also new to us and was just trying it out. And this is also what I would encourage you to. Yes, it looks scary. Yes, it's in the end somewhere 230 volts. But if you are cautious, then everything will be fine. Yeah. And with that, well, I want to say thank you. And I'm doing that now. So thanks a lot for having us here. Feel free to drop by. I'm happy to show the robot later on also.